In this video lesson, we're going to take a look at a hydrate problem where we're not given information directly, but we have to figure it out using some lab data provided. So using the equipment that you would see here. So when you do a hydrate lab, what you do is you put the hydrate in a container that we call a crucible. It's a nice heat-resistant container. You put the hydrate in there, and what you essentially do is you measure the crucible, the mass of the crucible first. You put the hydrate in there, you measure the mass of the crucible with the hydrate, and then you can figure out sort of what your mass of hydrate was using those two numbers. But essentially what you do after is you heat up the hydrate. There's a crucible cover on it too, so you can prevent splashing of the hydrate. But you heat it up until it's fully heated and all the water comes out. So you have to wait a sufficient amount of time based on the procedure provided. And then you reweigh the crucible and what's left over, and you'll notice that there's a difference in their mass. And so you have to use this information here to figure out things like the percent of water in the hydrate, and also calculating the formula for the hydrate. So let's go take a look at how to do that. We'll go to our handout and work on this problem together. I do encourage you to try to think of this on your own as well, right? You want to practice those thinking problems. You don't just want to watch someone do a problem every single time. You want to try it on your own, see if you can solve it. And then if you really can't, you can go ahead and try it and try to look at the video. But always try to solve it on your own first. With the background information you have, you'll be able to do that. So pause the video first, try it out, and then come back and check. So we need to figure out the mass, the percent of water in the hydrate. So essentially, just a reminder here, the mass percent of water is going to be equal to the mass of water divided by the mass of the entire compound, so the mass of the hydrate, times 100%. So we need to figure out what the mass of the water is. And there's a few ways you can do that. So this I'll put really as my step 0, because I'm not really there yet. It'll be our final step at the end. But we need to figure out what our mass of water is. And so, like I said, there's a few ways to do that. But one way is take a look at what the mass of your initial crucible and hydrate were. They were 14.013. And after you heated it, the mass of your crucible and your anhydrous was 13.792. So there's a difference in the mass there. And what can account for that difference? Well, it must be the water. Now, what's the point of doing the mass of the crucible and your compound in there? Well, it's a little bit better this way because you don't have to scrape your product out and risk spilling any or leaving any behind. So that's why we combine the two together. But just with some simple subtraction, we can figure out what the mass of water was. So we're just going to do the mass of the crucible and the hydrate minus the mass of the crucible and the anhydrous, the residue that's left over. So we'll have 14.013 grams minus 13.792 grams. And that difference will be the water, because that's what's coming out of the crucible when you're heating it up. So 14.013 minus 13.792. And we get 0.221 grams. So we have the mass of water. Now we just need the mass of the hydrate. So if you look carefully, you have the mass of the crucible, meaning the container. And then you also have the mass of the crucible with the hydrate in it. So if you want to figure out, well, the mass of the hydrate that you just put in, you can simply subtract these two values here. So the mass of the hydrate is going to be the mass of the crucible in the hydrate, 14.013 grams, minus the mass of the crucible itself, 13.513 grams. It's like if you had a container, like just think of it this way. If you had a container that weighed 5 grams, and then you put in, I don't know, some food, and afterwards everything weighs 25 grams, well, you don't have 25 grams of food. you have 20 grams of food because the container weighs 5. So you have to take that in consideration. So, 25 grams minus 5 grams, that would mean you have 20 grams of food in there, not 25 grams. So it's the same idea, except you're not dealing with food, you're dealing with a hydrate. And so when we do this, we get the 14.013 minus 12.513, and we get 1.5. So the 3 decimal places, 0 grams, because there's 3 decimal places here and here. And so that's the mass of the hydrate. And so what we can do now is basically go back to our step 0, which is really our last step is the mass percent of water is going to be the mass of the water we found. So 0.221 grams over 1.500 grams times 100%. Cancel out grams. We get 0.221 divided by that times 100. And we get approximately 14.73333 keeps going percent. Or we're going to round that to the correct number of sig figs. So I believe we have 3 sig figs here. So 14.7% H2O by mass. And so this here is our final answer for the percent of water in the compound. We didn't have a formula for it. We know it's a hydrate of barium chloride. So what we do know is that it's going to be a BaCl2.xH2O, but we don't know enough to find its molar mass. So we had to use mass data provided to us from the information that we have over here. So again, generally what you do when you do this lab is you weigh your crucible, the empty container first, then you put in your hydrate and you find the weight of the crucible and the hydrate together. And so that basically lets you know how much hydrate you put in. So you can just do the subtraction between the two there and you get your mass of hydrate. Then you take the hydrate and crucible, you heat it up until all the water's gone, and you reweigh the crucible with the anhydrous, the leftovers, and basically the difference between these two numbers over here will be the mass of your water that's there. And again, it's nice to weigh your container with your substances, with your chemicals, because you don't want to run the risk of losing anything when you try to take the substance out. So that's why we often weigh them together. So we found our first part, which is calculating the percent of water in the hydrate. Now what we need to do is calculate the formula of the hydrate itself. And so that's basically going to be doing the same steps we've done in previous problems here, just using our mass data. Remember that in our first step, we need to find the mass of water. And luckily, we've already done that. We found the mass of water by doing the above step. We did the 14.013 grams minus the 13.792 grams, and we got 0.221 grams of water. We also had to find the number of moles of water. So number of moles of water is going to be the mass of water over the molar mass of water, which is going to be 0.221 grams over molar mass of water, which is 18.02 grams per mole. Cancel out the grams, we're left with moles. So we get 0.221 divided by 18.02. And we get, I'm not going to round yet because we're going to be using this later on, but 0.012264415 moles of water. Now, we need to find the moles of the anhydrous, the ionic compound. So to do that, we need the mass of the anhydrous, the leftover, the residue. So we don't have that directly given to us like we did in previous questions. We have to go find it. So what you'll notice is that we have the mass of the crucible, and we also have the mass of the crucible with the anhydrous in it. So you can probably guess how to find the mass of just the anhydrous by itself, the residue. That's right, subtract 13.792 minus 12.513. So 13.792 grams minus 12.513 grams. Was that correct? 12.513 for the crucible. That's right. So you get 13.792 minus 12.513, and we get 1.279 grams. So now we can find the moles of BaCl2, by doing the mass of BaCl2 in our sample over the molar mass of BaCl2. And so we'll have 1.279 grams divided by the molar mass of BaCl2. So Cl2, that's 35.45 times 2. And then barium, I know we saw it earlier in the lesson, but I already forgot it. So let's go back and double check what barium is. 137.33 plus 137.33. We get 208.23 grams per mole. Cancel out the grams, and now we get 1.279 divided by that big molar mass. We get 0.006142246 moles of BaCl2. Now we can find our X value by dividing by small, doing our ratio. So remember, X is going to be the moles of water, which is bigger, over the moles of your anhydrous, which is BaCl2, it's smaller. So we'll get 0.0122645 moles of water divided by 0.006142246 moles of BaCl2. So let's go ahead and do that. So 0.01226415 divided by that smaller mole value, and we get 1.996688002, which we can round, because we're in that rounding region, to about 2. So what did we just figure out? Well, a couple things. Step 6, we know X is equal to 2. So our formula, we said it was a barium chloride hydrate. So our formula is going to be barium chloride, BaCl2, dot 2H2O, because we found that X value. And if we want to name this, we could say barium chloride dihydrate. So this was very similar to previous examples we did with hydrate calculations, except we gave you data that you would collect in the lab. This will be very useful for you when you do virtual or real labs. And if you have lab style questions, you can see some like this, where you have to use information about masses of containers, do some subtraction, and figure out what the masses of your initial compound was, a mass of water released. And it just allows you to think about the material in more practical ways. So I would attempt this problems a few times until you really, really understand it and you know why you're doing all the different steps. And at that point, you'll be a pro at finding the formulas for hydrates, especially in the context of a lab. So priority is to retry the practice problems within this lesson. Afterwards, head to the homework sheets where you can select a few that you might want to try to get some extra practice with. And you can also verify your understanding and earn additional feedback by doing the exit tickets found on Brightspace for the hydrate lessons.